Good morning, students. I am Nagamani, JL Chemistry, Naidupeta. Today we are going to discuss about the halogen as oxo acids of halogens. Oxo acids of halogens. We know that what are halogens? Halogens are fluorine, chlorine, bromine, iodine, and then astatine. Astatine is an radioactive element. It is an radioactive element. So its properties are different from the remaining elements. So we cannot discuss here about the astatine. So we will discuss only the fluorine, chlorine, bromine, and then iodine. So these are the main halogens which are participate in all of the chemical reactions. So what are oxo acids? When these oxides dissolves in water, oxides of these halogen atoms dissolves in water, they will give the oxo acids. Oxo acids. So those are called as oxo acids. What are the main oxo acids of halogens and what are their structures and what is the hybridization involved in it? So we will discuss about these all of things. What are the main oxo acids? Number one, what are the main oxo acids? And number two, that is hybridization. Number three, that is structures. What are the main structures of oxo acids? So we will discuss. And next one is the strength of the oxo acid strength of acids. So these four things we will now discuss about these oxo acids of halogens. So first of all, what are the main oxo acids of halogens? The main oxo acids of halogens are we will draw in a picture. So there are what are the main oxo acids of halogens? So name of the oxo acid, name of oxo acid and halogen element. Halogen elements. What are those halogen elements? Fluorine, chlorine, bromine, iodine. So first of all, we will write the name of oxo acid. So first one is halo acid. Halo acid. So these are called as the halo acids or halic acid. Halic acid 1, that means the oxidation state of the halogen atom which is 1, it is called as halic acid 1 or hypohalous acid. It is also called as the hypohalous acid. And number 2, second one is the halic acid 2. Halic acid 2, that means the oxidation state of the halogen atom it is +2, so it is called as halic acid 2. So it is also called as, or it can be called as halous acid. It is called as the halous acid. And number 3, that is halic acid 3. Halic acid 3, or it is also called as halic acid. And fourth one, that is called as the halic acid 4. It is also called as perhalic acid. So we will know the structures of each halogen atom. First one is halo acid. What is halo acid? Halogen elements in fluorine gives only hypofluorous acid, that is HOF. Hypofluorous acid. It is the most common halo acid of the fluorine. It gives only hypofluorous acid. In this hypofluorous acid, fluorine contains its oxidation number of fluorine, it is +1. So this is the only oxo acid of the fluorine. whereas the chlorine gives hypochlorous acid, that is HOCl. Hypochlorous acid, it is the HOCl. Bromine gives hypobromous acid, HOBr, and iodine will also gives the hypoiodic acid, that is HOI. And the next one, hypohalous acid 2. That means the oxidation number of the halogen atom, it will be plus 2. So that this is called as the halous acid. This halous fluorine does not give any type of halous acid, whereas chlorine gives one type of halous acid, that is HClO2, that means HOClO, that is chlorous acid. It is called as the hypochlorous acid. This one is chlorous acid, whereas bromine and iodine also gives the HOBr2, HO2Br and HO2I, bromous acid and then iodous acid. Next one is the halic acid 3. So fluorine does not give that halic acid 3, whereas chlorine it will give HClO3. It is called as the chloric acid. Bromine and iodine will also give the bromic acid as well as iodic acid, that is HBrO3 and HBr H HiO3. And next one is the halic acid 4, that is perhalic acid. Fluorine does not give perfluoric acid, but chlorine gives the perchloric acid HClO4, whereas bromine it will give HBrO4 perbromic acid and HiO4, it is called as the periodic acid. So these are the halogen acids of the oxo acids of the halogens. Fluorine gives only hypochlorous acid, whereas chlorine gives 4 types of oxo acids, that is hypochlorous acid, chlorous acid, chloric acid and then perchloric acid. Whereas bromine it gives 3 types of acids, that is hypobromous acid, and bromic acid, perbromic acid. Iodine will also give 3 types of oxo acids, that is hypoiodic acid, iodic acid and then periodic acid. So these are the main oxo acids of the halogens. And next one, what are the structures of these oxo acids of halogens? What are the main structures? We will discuss the structures of chlorine, oxo acids of chlorine, because all the structures will also in the same manner. So we will discuss one a typical study of the chlorine acids, oxo acids of chlorine. So what are those oxo acids of chlorine? That is, we have already known, that is HOCl hypochlorous acid, HClO2 that is chlorous acid, HClO3 chloric acid and then HClO4 it is perchloric acid. So now we will go to the calculation of oxidation number in each of the acid chlorine for the chlorine atom. So in HOCl, that is the central atom is chlorine. Here the central atom is the chlorine. It contains +1 oxidation state. It contains +1 oxidation state. Whereas in HClO2, the chlorine atom is the central atom. Here it is also having the +3 oxidation state. In HClO3, the central atom is chlorine. It exhibits +5 oxidation states. In perchloric acid, that is HClO4, central atom is chlorine. It exhibits +7 oxidation state. So these are the oxidation states of the oxo acids of chlorine, that is +1, +3, +5 and then +7. And next one is what is the hybridization involved? this one, and hybridization involved. What is the hybridization? In all of these oxo acids of chlorine has only one type of hybridization, that is sp3. All are sp3 hybridized orbitals. So sp3 hybridization means one s orbital and 3 p orbitals are mixed together give a 4 sp3 hybrid orbitals. 4 sp3 hybrid orbitals. Suppose if we concern for the HOCl, first atom is HOCl, we will describe the structure of HOCl according to the hybridization. So first of all, the central atom is chlorine. So its outermost orbit is 3s orbital and then 3p orbitals. 3s and then 3p orbitals of the chlorine. So this one is 3px, py and then pz. So 3s orbitals, its outermost configuration is 3s2 3p7. 3s2 3p7. So there are 3 lone pairs and 1 unpaired electron. These are present in the chlorine outermost orbit. When these 4 orbitals are come together and give a hybridized orbital of 4 sp3 hybrid orbitals. 4 sp3 hybrid orbitals. Total electrons are 7. When these electrons are equally distributed, 3 of them are having paired electrons and 1 unpaired electron. So we will give the structural representation of sp3 hybrid orbitals. There are 4 sp3 hybrid orbitals. So 3 of them are having the lone pairs and 1 single electron. This single electron will be combined with the OH group. Single electron will combine with the electron present in the OH group. So that is the structure of, so this contains, we will easily explain that in HOCl there are 3 lone pairs and 1 bond pair. 3 lone pairs and then 1 bond pair. So it is a linear in structure. The structure of the HOCl is linear. It contains 3 lone pairs and 1 bond pair. So due to this repulsion in between the lone pairs and bond pairs, it will conform to only the linear shape. That is about the HOCl, that is hypochlorous acid. And second one is the chlorous acid, that is HCl2. HClO2. Its hybridization is sp3. So simultaneously we can explain this structure will also by representing the 4 sp3 hybrid orbitals. So these 4 sp3 hybrid orbitals, there are 3 lone pairs and 1 bond pair in OH group, whereas it is having the +3 oxidation state. It will contains only 2 lone pairs and 2 bond pairs. That means 2 OH groups are present. 2 lone pairs and then 2 bond pairs. And there is a double bond O. Here there is a double bond O. That means it contains 2 lone pairs. 1 p pi d pi bond. 1 p pi d pi bond is present in the HCl2. And next one is, so we can draw this structure as chlorine atom, OH, double bond O. So that is about the structure of chlorous acid. And next one is the chloric acid. Here it is also undergoes sp3 hybridization. 4 sp3 hybrid orbitals are present. So here there are 2 lone pairs. There are 2 unpaired electrons and 2 bond pairs. So it will be combined with OH group. One OH group is there and 2 double bond O. That means Cl, OH. One lone pair is there. Here the lone pairs are 1 lone pair. two double bonded oxygens are present. So its bond angle is 1 degrees. Bond angle is the 1 degrees, and the shape of the due to the presence of one lone pair on the chlorine atom, the shape of this molecule is pyramidal. Shape of this molecule is pyramidal, whereas in chlorous acid its shape is V shape. This one is linear V shape and then pyramidal shape. And the next one is the HClO4. It is also having sp3 hybridization. So 4 sp3 hybrid orbitals are present. Here one is having the one OH group. OOH, perchloric acid, means these electrons are bonded with the another oxygen atom and then hydrogen atom. So here there are 2 p pi d pi bonds. 2 p pi d pi bonds. So the structure will be, the central atom is chlorine, one OH is there, OOH is there, and 3 doubly bonded O. So 3 double bonds, that is 3 p pi d pi bonds are present. Here in the chloric acid there are 2 p pi d pi bonds are present, and here it is 1 p pi d pi bond is there. So due to this structure, it is a tetrahedral structure. It is the tetrahedral structure. So these are the structures and hybridizations of the oxo acids of chlorine. This is very much important for the essay question. And the next one is the acid strength. Acid strength. So about the acid strength. The acid strength of this chlorine acids, that is HClO, that is hypochlorous acid, is less than the HClO2, it is less than HClO3, it is less than HClO4. That means HClO, it is a least acid, that is less acidic, whereas perchloric acid HClO4, it is the most acidic. So that acid strength decreases from HClO to HClO4. Why? Because here HClO, in HClO, hypochlorous acid, the bond between the chlorine and oxygen is the more strengthy. So the electronegativity of the chlorine, it is greater than the oxygen, so it attracts the lone pair of electrons from the chlorine from the oxygen atom. So when the electron density decreases over the oxygen atom, it strongly binds the hydrogen atom. So it cannot releases easily the H plus ion. It cannot release the easily H plus ion. So it is a least acidic. So when we call it them as a strong acid, when it releases readily the proton, so then only we will call it as a strong acid. HClO, it does not give the proton because the bond strength between the oxygen and hydrogen is heavy. So it does not releases readily the H plus ion, so it is a weak acid. As the HClO2, HClO3 and the HClO4, as acid strength gradually increases here. Why? Because these acids they will stabilize the halous ion, that is chlorous ion ClO2 minus ion. The stability of ClO2 minus ion is greater than the ClO3 minus ion, and it is greater than ClO4 minus ion, where the anion strength increases, anion stability of anion increases. When the stability increases, they will readily lose the proton. So the acid strength gradually increases from hypohalous to the chloric acid and then perchloric acid. That is about the stability of hypohalous acids. Hypochlorous acid, chloric acid and then perchloric acid. Whereas in hypohalous acids, that is HClO is greater than HBRO. It is greater than the HIO. That means as the size of the halogen increases, size of the halogen increases, so the bond strength will be decreases. So the HClO is more stronger than the HBRO. It is more stronger than the HIO. That is about the acid strength and the structures of the halogen acids. So it is very very important for the IP exams, simultaneously the MSET examinations also. If you have any doubts, call your teacher and ask your doubt and clarify your doubts as per your convenient. So okay.